First Order is preparing to invade Crait, and we need you to develop a simulation to maximize our forces and minimize casualties. I'm counting on you to develop this, but if you fail, you'll answer directly to me. So don't fail and wipe the Resistance.
You've heard the Supreme Leader. Your next assignment is one of critical importance. Therefore, there will be no room for mistake. Let us begin talking about it. What you see here is what we expect from you. We are going to be invading Crait. And in order to simulate what the most effective invasion will be, we need you to create a map that we can control and that we can plan our attacks. We want to minimize our casualties and maximize our effectiveness and damage upon the Resistance. Today we wipe the Resistance out, so do not fail the First Order. As you can see here, what you will be getting from us is going to be a main function, and this main function is going to be calling different functions that you are to develop from different classes that you are also to develop, that will simulate attacking infantry, attacking armor, and potentially attacking even artillery forces. For the infantry, we will have our stormtrooper squads. For the armor, we're going to have our AT-ATs that are brand new and improved. And then for the artillery, we will have the AT-MAs. We expect the Resistance to contain for armor speeders. Infantry for the Resistance is just some rebel scum and some rusty tanks that they might have in action. We don't expect much resistance, but then again, we must not underestimate the Resistance. So, this is what your map should look like. As you can see, it is a two-dimensional array that is going to be dynamically allocated, in which you are going to be able to select a coordinate from here and be able to put in a tank, an artillery unit, or even infantry squads. Because infantry squads are very important and our stormtroopers don't really aim very well, we just like to put a lot of them together so that maybe one of them will hit. Therefore, for the infantry squad, we are going to be having an array of them so that we can have more than one. But we will only be able to have one armor squad or one artillery squad maximum per point in the map. So that is maximum of one armor and one artillery and an unlimited amount of infantry in an array. So those are your three main items that each point may or may not contain. Each point is going to be what is known as a point object. Very convenient name. It was the Supreme Leader's idea. So, to represent each of these units, we will be picking individual characters, such as T for tanks or armor, A for artillery, and I for infantry. However, when one point contains multiple units of the same type, because we like to bunch them up together for maximum defense or offensive, they will contain different characters. Such as, for example, if all units are contained of three types, we will put an exclamation point to indicate that. I will discuss later the other special characters that we use. As you can see from the main function here, we have things such as add infantry. For adding infantry, the main thing is we are going to be selecting a point within the map in the form of X and Y coordinates. However, the first of the two is going to be the Y coordinate and then the X coordinate. Yes. So that's going to be the point where we are going to be adding our infantry squad. And then this is the amount of infantry squads that we would like to add. This is why it's an array. And then we can give them a name or we can pass in some default. In this case, you're going to be getting this main function, so we need you to be able to do this because this is how Kylo Ren wanted it. You can also add to the same position more infantry squads, and in that case, you're going to take your dynamically allocated array, make a new one that is as big as the old one plus the new infantry squad array size, bunch them up together, make a new one twice the size, delete the old one, replace it with the new one, easy. When it comes to armor, there isn't much other than just basically saying new armor, and again, you are being given this, so you don't have to worry about it as long as behind the scenes it works. Same goes for artillery. Really, the tricky part is going to be your infantry because it's an array of them and there may or may not be an array already there. If there isn't one, it's easy because you just make a new one and link it there. But if there already is an array there, like I said, you are going to take the old array, you are going to copy its content into a new array, and then after those items, you're going to add the new ones. So you got to figure out how big the array is. And as an added difficulty, because the Supreme Leader wanted it this way, there is no size variable that decides how big the array is. You are going to have to make the array +1 bigger to put a null at the end of it, and then count until the null to see how big it is. This may seem like an unnecessary difficulty added to the program, which it is. However, it's also good preparation for when we learn about linked lists later on and using the null as a way to detect the end of a list of items. So it's good for you. We are going to be simulating the resistance because we need to be able to test our weaponry in our simulations. And so we are putting some points for them to spawn, and then we're able to attack them. We have two main attack functions. We have attack move, which is strictly limited to being used on tank units for the tank units to attack other tank units. In other words, armor against armor, which in our case is our mighty AT-ATs against their measly speeder bikes. Yes. And so the way the function works is we have our origin point where the tank, our glorious AT-ATs are located, and the destination where the enemy's speeder bikes are. And so our high accuracy ensures us that whenever we do an attack, they will always be guaranteed to be destroyed. The other one we have is for our artillery units, which we use the fire at function. In this fire at function, we have an origin and a destination, similar to the attack move one. But in this case, our artillery is of the best kind. Supervised by the Supreme Leader, this artillery is guaranteed to wipe out not just tank units, but every single unit that is in that point, whether it be armor, infantry, or other artillery units. So, let us show you the might of this weaponry. As you can see, after running that main function here, this is the map that's generated. You can see the number here is going to indicate how many infantry squads are in that point, along with the characters that indicate the type of units that are found there, such as I for infantry. But again, we use other symbols when we have multiple types of units found in there. Here is an example of us using the functions. So after we do the draw function, which actually generates this map, we go ahead and we do two attack moves and a fire at. The first attack move was intentionally not aimed at a place where there were units so that we could test our weaponry. And as you can see, when we try to attack, it says that there is no armor available. So there's no armor in the point that we're trying to use to attack, so it just does not do anything. But more importantly, the program does not crash. We cannot allow our simulations to crash when they're we're relying on them for the assault. They must be robust. In the next one, we can see an attack where we're basically in this case, we're simulating the resistance, a potential risk of the resistance attacking our tanks or AT-AT. So we have a speeder moving to position 5-1, which is going to match this attack move here, which you can see there in positions 1-4 and going to 1-5. The reason why you see 5-1 here instead of 1-5 is because the first of the two indices for the array is the Y and X here. So this is Y and then this is X. Whereas here we're showing X comma Y because that is easier to read for humans. And so in this case, that is why it's saying that the speeders are moving from basically 4-1 to 5-1. And it shows because they effectively destroyed the AT-ATs. Again, this is just a simulation. We will have to prepare for the worst. But of course, that will not happen. An example of the artillery here, fire at, can be shown here, where we can see our ATMA fires at position 3-2, which you can see here. Again, the source is this is where the artillery is, so it's at 8-4, and it's firing at 3-2. And it shows you before destroying what was contained in that point before the massive, glorious destruction of the units happened. So as you can see, we hit some rusty tanks acting as decoys, damaged artillery, and we also destroyed a bunch of decoy soldiers that we put there for testing purposes. Apparently we had about 11 of them, 1 to 12, but not counting 0, so 11. All units were destroyed, showing the true mightiness of our first order artillery, ATMAs. The map is then drawn after the live fire is conducted, and we can see the result. So let us see how that tank unit worked. So we can see that the speeder here attacks the AT here, which then now becomes nothing here because now the speeder is going to end at the position it attacks. So it moves there physically. Because these are pointers, you have to physically take the pointer, copy it over to the new spot, and make sure you set it to null before so that you don't have accidentally two places pointing to the same location. The artillery is at here. This is the artillery right here, and it's going to be attacking and destroying. Let's see, what is it? Destroy. It's destroying 2, 3. So that is probably going to be this one right here. As you can see, it goes to 0. So it wiped all units out. Proof that our artillery works. And so that's the gist of the program. So now I'm going to go ahead and talk about some of the classes and how they're implemented and the functions that support this program. So at the heart of this, we have a superclass, and that superclass is going to be the entity type. This class's job is not really used in the program directly. It's just used it's just inherited by other units, and it mostly allows us to keep us the name of the unit. But it also has an ID system that, while in use right now, is very useful to have and could be used in the future to identify every time a unit is created or destroyed. So in the entity class, you want your constructor to assign a name to the string variable that the entity class is to contain. The string variable must be dynamically allocated, which means that in your constructor, you're going to have a new call, something like new string, and then you're going to assign it a parameter. So a constructor is going to look something like this. And then you can set some default, which I would recommend you choose none like that. And then in here, you're going to have a new call, and then you're going to assign the variable from n into that name, into that name string pointer. So it's going to look something like this, but this is not intentionally. I'm not completing this because it's a pointer. It requires one more thing right here. Hopefully you know what that is, or the supreme leader will not be happy. Okay, similarly, because you're using dynamic memory allocation for that string variable, you are going to be needing a destructor that is going to deallocate that name string, because this program must not have any memory leaks or dangling pointers or any errors when you run it on Valgrind. The supreme leader will be checking if there are memory leaks. And we all know what happened when the secret Death Star plans leaked out. So we don't want something like that to happen here. There must be no leaks in our security. No memory leaks allowed. Make your name variable protected so that you can do inheritance successfully. From there, this entity class will be inherited by 3 new classes that are going to represent your infantry, your armor, and your artillery. They are conveniently named Infantry Squad, Armor Squad, and Artillery Squad. We were going to include one for air to have our glorious TIE fighters, but we don't expect the enemy to have any air units to support them, and so we don't need to worry about that. These classes will be rather simple. All you really need to do is a constructor for them that passes in a name parameter into the parent class. I'm going to give you an example by giving you the Infantry Squad one. So for the Infantry Squad, what your constructor will look like will be something along these lines. You can have a default name, which can just be Infantry Squad, which of course will be replaced by things like Stormtrooper Squad, which is what you'll actually pass the constructor in. But it's still good to have a default. And then you will call the parent constructor and pass that name variable. And that's literally going to be your entire constructor. All 3 constructors should look very similar to that. Moving on to the more interesting part, we have the point class. So this point type class is going to contain, the most important part is it's going to contain 3 pointers. These 3 pointers are going to represent your armor, your artillery, and your array of infantry. I conveniently call them arm, art, and infantry. These 2 should be 1 pointer type, but because this one's an array, it should have two pointers basically, because it holds a one-dimensional array of pointers, which that's why you put 2. Your constructor for this class should set all these 3 pointers to null initially to avoid problems. We consider null to signify where a point in the map has nothing in it. It's in like no infantry, armor, or artillery. That way we're able to figure out whether there is a unit in the map or not at that. If there is a unit in that point of that type in there. Make sure you have a destructor as well. This destructor should deallocate any remainder units that are when the map simulation ends. Take particular careful attention for the infantry array because it is an array, and like I said, there is no size variable for the array. So to do that, what you're going to do is when you're making an infantry array, what the infantry array really is, it's a bunch of pointers. And these pointers are of infantry type. Okay? These pointers are initially, well, they don't exist, but when you make the array initially, what you're doing is you're going to be loading them with each infantry squad, which is going to be contained here. However, for the last one, you're going to make one extra space in the array and you're going to set it to null. So that way, whenever you need to find out what the size of the array is, you can just go in a loop that traverses this array until it hits the null, and then of course keeps track of that count. So that is how we're going to ensure that we don't have a counter in our class, but still be able to effectively manage the array size. This is very similar to how back in the day, strings, in C, we have null terminated stuff, and that's how we were able to keep the size of a string by just counting until we got to the null. It's very important that you don't mess up this null, or you might have a bunch of sec faults. Similarly, when you're deallocating, make sure that you deallocate each of what these pointers are pointing to, and then at the end, deallocate the array itself. The point class should also have a print function that allows you to print what is contained in the object of the point. That is seen on the output that I just showed you, where it shows when you are destroying something in a point. So let me show you that again. This right here is actually me calling the print function, at least up until here, not the all units destroyed part. It tells you the coordinates of the point, it tells you what's in that point, and of course when you're calling this to destroy something, I just call the print there and then say destroy. Makes it very nice and convenient. Again, when you're printing out that array of infantry there, you are going to have to be using this loop system until you hit the null to be able to print out all elements of the infantry array. There's also a function called getCar, which is a car returning function. The job of this function is to translate based on what units are contained in that point, what character you should draw on the map. So let's go over that list. These are going to be the different characters that you could return: a 0, an I, an A, a D, a T, a C, a B, and an exclamation point. You can think of this as binary. Where this is going to be your armor, this is going to be your artillery presence, and this is your infantry presence. Okay, So basically, if you see a 0, it means that that pointer is null. So for example, when you see a 0 on the map, it means there's no units there. And that's because the armor pointer, the artillery pointer, and the infantry pointer are all set to null. And so when you check that with an if statement, so you can say something like, if arm is equal to null and art is equal to null and infantry is equal to null, then you can just say return 0. So the variation here is you're going to change the equal to not equal. So for example, in the second line here, you're making the infantry not equal. So what this is saying is when there's no units there, you get a 0. When you only have infantry units, you get an I. When you only have artillery, you get an A. When you have no armor, but you have artillery and infantry, you get, oh, this one's a little bit not clean, but it's a D, delta. Here it's when you have armor, but no artillery and no infantry, you get a T, tank. Here you have armor and infantry, but no artillery, you get a C. Here you have armor, artillery, but no infantry, you get a B. And then when you have all of them, you get an exclamation point, okay? So each of these should be basically one if statement if, else, if, and then you just do that 9 times. Maybe there's a smarter way. This was quick and clean. A little bit Yandere dev style, but okay. All right. There is a function that, if you notice, let me go back to the print statement here. You can notice that you see some numbers followed here by the character of the type. Those numbers are representing infantry squad amounts. So every time there's infantry in that spot, you are going to be looking at a number after that. That number represents the infantry count in that position. So for that, we have a function that is known as get infantry count. This one returns a string because we're really returning potentially two characters. So I wanted to make sure that, a string. So again, just count how many, if there is infantry. If there's no infantry there, just return 2 empty spots. It's literally 2 empty spots, so it fills it up and lines it up nicely. You could use fill, W, whatever you want, but either way, just make sure you return 2 spots here. In the case that there is infantry, you run the loop, you count it, and then you get that number, and then I suggest you use the toString function that is part of std. You don't need to put that because you're using namespace std, but just FYI. And then return there the count variable where you're keeping track. It's an integer. So return that value. Okay? What that's going to be doing is it's going to convert your number into a string. And then for all of the examples, and because we have great numbers, we always have more than 10 number of infantry there, so you don't have to worry about lining it up. But if you would like, you can use set fill for that to make sure that it's always lined up nicely, so that if you have a single number in squads, it doesn't shift the map and make it look weird. Okay, there is also an X and Y. If you just keep track of where the point is located, it's nothing important to talk about there. No point to that. Next, we have the map type class. The map type class is like your whole map. It contains what is essentially like a 2-dimensional array of points. So that map is, or 2D array is also dynamically allocated. So you are going to need something like that. But of course, don't use the syntax. It would have to be that, and we call it conveniently point. Okay, so this is contained within the class, and it also contains X and Y, but that X and Y represent actually the dimensions of the grid. So basically how wide it is and how tall it is. Again, the X we use as the second. So when we have a point, Again, it's formatted like this because when you go down, that's that first dimension, and it goes like that. When you go this way, it's the second dimension, and it's this one. Okay? So that's why we've formatted like that, with the Y and the X like that. But when you print it out for humans to read, it's easier to print it out like that. Okay? So make sure you think of that logic of the fact that the bottom left, or sorry, top left is 0, 0. Okay? So going back to the map, because you do have that two-dimensional array of points, in your constructor, you're going to have to dynamically allocate it and make sure you set the X and the Y for each individual point so that it copies this over to the point array. And then for the destructor, make sure you also deallocate that array as well. There are a couple of functions that I would like to talk about within the map function. Some of them you've already seen. We have draw. We have the attacking function, so the fire at. And then we have add infantry, which is used to actually add infantry to the map. Whereas with the artillery and the armor, you just do an assignment with the new operator. Add infantry is a full function to make it easier to add things and check for other specifics. And then of course attack move. These are the 4 functions that you need to do for that map or public. So let's talk about attack move first. Attack move, again, what you're doing is you have an origin point and a destination point. So those are the 2 parameters you have. You check, again, first you check whether the origin is, if there's no armor in the origin point, so if the origin armor is set to null, then you just say no armor available, you do nothing. Otherwise, if there is armor, then you're going to try to move it there, and where you're moving it to, there happens to be armor as well. Then you go ahead and destroy it. If there isn't any armor, then you just move it there without signifying a message of destroyed. For the fire at function, the artillery doesn't move. It just simply fires. So the code is similar to the attack move, but the difference being that what you're doing is, first of all, you're checking if there's artillery available. If there isn't, then you do nothing. If there is artillery, then you basically say it fires at, you put the point coordinate, and then there what you're going to do is you're going to deallocate everything that is in that point that you just fired at. Hint for this is I just call the destructor of that point and call it a day on that. So that can work. Just be careful you don't have any issues with background. Add infantry is probably the most complicated function of the program just because of the logic involving it with the array that I've been mentioning. So the first thing you do is if you check if it's null. If it is, then it's easy. You just make a brand new array of the size that you need it, and then dynamically allocate each of the entries with an infantry squad. If it's not empty, then what you got to do is what is essentially a deep copy. So you have to make you have to count first how big the array that you have is. Once you have that number, then add the number of things that you want to add plus the number that you want plus 1 for that null extra at the end. And then go in there and allocate a new array of that size. Once you've allocated an array of that size, take the old array in a loop and copy it over to the new array. So you're going to copy the old contents so they go in first. After those go in, then add in the new ones afterwards. And then at the end, don't forget to add that one null because that's what you use to stop because there's no size variable. That's the whole logic of it. Do it in that exact order and you'll be okay. One more thing though, however, is once you finish all that deep copying, make sure you delete the old array that you had. So you got to run through a loop to delete it again. Do all your deletes and everything. And the last thing is update the infantry pointer to the new array that you made. So this whole time, make a temporary array with a temporary pointer to that array. And all you got to do then is just assign that pointer to the point's infantry location so that it updates it. So make sure you do that one last bit, otherwise the whole thing will be lost and there'll be memory leaks and bad things will happen. And I guess draw. So for draw, that one's pretty trivial. All you're doing is just running into the point array, and then for each one, you're going to see out the get car so that you see out the right character. Then see out the get infantry count, so you see out if there's any infantry in any spaces, and then add one extra space and some line, a line feed at the end so that it looks nice, and a line feed after each line. So you'll figure it out. Just format it so it looks the same, because that's the way Kylo Ren wanted it. That's it. That's the assignment. So if you have any questions, please send me a hologram, and I'll get back to you as soon as possible. But for now, get working. The invasion must happen soon, before the resistance calls for help. So we're counting on you. Don't disappoint Kylo Ren.